Tsung-Dao Lee is a Chinese-born American physicist, known for his work on parity violation, the Lee model, particle physics, relativistic heavy ion physics, non-topological solitons and soliton stars. He holds the rank of University Professor Emeritus at Columbia University, where he has taught since 1953 and from which he retired in 2012. In 1957, Lee, at the age of 30, won the Nobel Prize in Physics with C.N. Jiang for their work on the violation of the parity law in weak interactions, which Chen Qiongwu experimentally verified. Lee was the youngest Nobel laureate after World War II until Malala Yousafzai was awarded the Nobel Peace Prize in 2014. He is the fourth youngest Nobel laureate in history after W. L. Bragg, Werner Heisenberg and Malala Yousafzai. Lee and Yang were the first Chinese laureates. Since he became a naturalized American citizen in 1962, Lee is also the youngest American ever to have won a Nobel Prize. Biography. Family. Tsung-Dao Lee's ancestral hometown is Suzhou, Jiangsu Province. TD was born in Shanghai. Lee's father, Chun-Kang Lee, one of the first graduates of the University of Nanking, was a chemical industrialist and merchant who was involved in China's early development of modern synthesized fertilizer. Lee's grandfather Chong-Tan Lee was the first Chinese Methodist Episcopal senior pastor of St. John's Church in Suzhou. Lee has 4 brothers and 1 sister. Educator Robert C.T. Lee is one of T.D.'s brothers. Lee's mother Chang and brother Robert C.T. moved to Taiwan in the 1950s. They were accidentally jailed in Taiwan during the White Terror. Early life. Lee received his secondary education in Shanghai, Suzhou and Jiangxi. Due to the Second Sino-Japanese War, Lee's high school education was interrupted, thus he did not obtain his secondary diploma. Nevertheless, in 1943, Lee directly applied and was admitted by the National Chekiang University. Initially, Lee registered as a student in the Department of Chemical Engineering. Very quickly, Lee's talent was discovered and his interest in physics grew rapidly. Several physics professors, including Xu Xingbei and Kanchang Wang, largely guided Lee, and he soon transferred into the Department of Physics of National Chekiang University, where he studied in 1943–1944. However, again disrupted by a further Japanese invasion, Lee continued at the National Southwestern Associated University in Kunming the next year in 1945, where he studied with Professor Ta-Yu Wu. Life and research in the USA. Professor Wu nominated Lee for a Chinese government fellowship for graduate study in the USA. In 1946, Lee went to the University of Chicago and was selected by Professor Enrico Fermi to become his PhD student. Lee completed his PhD thesis under Fermi in 1950. Lee served as research associate and lecturer in physics at the University of California at Berkeley from 1950 to 1951. In 1953, Lee joined Columbia University, where he remained until retirement. His first work at Columbia was on a solvable model of quantum field theory better known as the Lee model. Soon, his focus turned to particle physics and the developing puzzle of K-meson decays. Lee realized in early 1956 that the key to the puzzle was parity non-conservation. A Lee suggestion. The first experimental test was on Hyperion decay by the Steinberger group. At that time, the experimental result gave only an indication of a 2-standard deviation effect of possible parity violation. Encouraged by this feasibility study, Lee made a systematic study of possible P, T, C and CP violations in weak interactions with collaborators, including C.N. Jiang. After the definitive experimental confirmation by C.S. Wu and her collaborators of parity non-conservation, Lee and Yang were awarded the 1957 Nobel Prize for Physics. In the early 1960s, Lee and collaborators initiated the important field of high-energy neutrino physics. In 1964, Lee, with M. Nauenberg, analyzed the divergences connected with particles of zero rest mass, and described a general method known as the KLN theorem for dealing with these divergences, which still plays an important role in contemporary work in QCD, with its massless, self-interacting gluons. In 1974-75, Lee published several papers on a new form of matter in high density, which led to the modern field of RHIC physics, now dominating the entire high-energy nuclear physics field. Besides particle physics, Lee has been active in statistical mechanics, astrophysics, hydrodynamics, many-body system, solid-state, lattice QCD. In 1983, Lee wrote a paper entitled, "Can Time Be a Discrete Dynamical Variable?", which led to a series of publications by Lee and collaborators on the formulation of fundamental physics in terms of difference equations, but with exact invariance under continuous groups of translational and rotational transformations. Beginning in 1975, Lee and collaborators established the field of non-topological solitons, which led to his work on solitine stars and black holes throughout the 1980s and 1990s. From 1997 to 2003, Lee was director of the RIKENBNL Research Center, which together with other researchers from Columbia, completed a 1 teraflops supercomputer QCD-SP for lattice QCD in 1998 and a 10 teraflops QCD-OC machine in 2001. Most recently, Lee and R. Friedberg have developed a new method to solve the Schrödinger equation, leading to convergent iterative solutions for the long-standing quantum degenerate double-wall potential and other instanton problems. They have also done work on the neutrino mapping matrix. Educational activities. Soon after the re-establishment of China-American relations with the PRC, Lee and his wife, Hui-chan Jeanette Chin, were able to go to China, where Lee gave a series of lectures and seminars, and organized the CUSPEA. In 1998, Lee established the Chan Sung Endowment in memory of his wife, Hui-chan Chin, who died 3 years earlier. The Chan Sung Scholarships, supervised by the United Board for Christian Higher Education in Asia, are awarded to undergraduates, usually in their second or third year, at 5 universities, which are Fudan University, Lanzhou University, Soochow University, Peking University and Taiwan National Tsinghua University. Students selected for such scholarships are named Chun Sung Scholars. Personal life. Chin and Lee were married in 1950 and have 2 sons, James and Stephen. Lee reads whodunit novels when not working on physics. The English speaking of his given name of Lee differs dramatically from the Chinese romanization systems in use at the time of his childhood. Wade Giles and Guoyarome C. Tsung-Dao Lee's publications are all under the name of T.D. Lee. Honors and awards. Nobel Prize in Physics. G. Bede Medal, Collège de France. Galileo Galilei Medal, Order of Merit, Grande Official, Italy. Oscar Klein Memorial Lecture and Medal. Science for Peace Prize. China National International Cooperation Award. Matteucci Medal. Naming of small planet 3443 as the 3443 Lee Tsung-Dao. New York City Science Award. Pope Johannes Paulus Medal. Minister Odile Interno Medal of the Government of Italy. New York Academy of Science Award. The Order of the Rising Sun, Gold and Silver Star, Japan. Memberships. National Academy of Sciences, American Academy of Arts and Sciences, American Philosophical Society, Academia Sinica, Academia Nazionale dei Lincette, Chinese Academy of Sciences, Third World Academy of Sciences, Pontifical Academy of Sciences, Bibliography, Technical Reports. Conservation Laws in Weak Interactions, Columbia University, United States Department of Energy. Weak Interactions, Columbia University, United States Department of Energy. Elementary Particles and Weak Interactions, Brookhaven National Laboratory, United States Department of Energy. History of Weak Interactions, Columbia University, United States Department of Energy, July 1970. Energy, Electromagnetic and Weak Interaction Processes, Brookhaven National Laboratory, United States Department of Energy, January 11, 1972. Books: Lee, T.D., Particle Physics: An Introduction to Field Theory. Newark, Harwood Academic Publishers. ISBN 3-7186-0032-3. Lee, T.D., Feinberg. Selected Papers, Vols 13. Boston, Basel, Stuttgart. Berkhauser. ISBN 0-8176-3344-8. Lee, T.D., ed. R. Novick. 30 Years Since Parity Non-Conservation. Boston, Basel, Stuttgart. Berkhauser. ISBN 0-8176-3375-8. Lee, T.D., Symmetries, Asymmetries, and the World of Particles. Seattle, University of Washington Press. ISBN 0-295-96519-3. Lee, T.D., Ren. C. Pang. Selected Papers, 1985-1996. Amsterdam, Gordon and Breach. ISBN 90-5699-609-6. Lee, T.D., Science and Art. Shanghai, Shanghai Scientific and Technical Publisher. ISBN 7-5323-5609-4. Lee, T.D., The Challenge from Physics. Beijing, China Economics Publisher. ISBN 7-5017-5622-8. Lee, T.D., Cheng, G. Huizhu, Lu, Li, Teng. Response to the Dispute of Discovery of Parity Violation. Lanzhou, Gansu. Gansu Science and Technology Publishing House. ISBN 7-5424-0929-8.